Yes. When the last class, right, actions, whenever action is performed, the flow executes from its root OTT. The following are some of the actions: collect, count by key, count by value, take, top, first, reduce sum, max, min, count, save as text file. I discussed about collect, count by value, count by key. 1 second. Meanwhile, I'll start this. So the services are running. Right, 1 second. JPS, control L, right. Now series Pyspark, Pyspark, right? Yes. Control L, right? Yes. Mhm. Mhm. So what was the last one we had discussed, right? Count by key, take, drop, right. First. Last one was first. Now reduce. Next is what? Reduce. Reduce some max, min, count, and save as text file, right? Now eight. Reduce. Reduce, right? Yes. Combines are sums, the elements of a RTD. Combines are sums, the elements of an RTD. Yeah. Observe this, right? Yes. X is a list. 10, 20, 30, 40, 50. 10 to 50, we have got a list. Okay, from this list, I want to create an OTD. R1 equal to S. R1 equal to SC dot parallelize. SC dot parallelize of X. SC dot parallelize of X. R1 dot reduce. R1 dot reduce, right? Mm. SC dot R1 is an RTD. On an RTD, I'm applying reduce sum. Reduce is an action. Lambda x comma y equals x plus 1. Cumulative sum. What is the difference between reduce and reduce by key? What is your observation between reduce and reduce by key?
Reduce by key will give you a key value combination,
Yes,
and
exactly.
here it will get one scalar value of some.
Reduce by key compulsory key comma, it can be applied only on key comma value pair. Output 150. Reduce can be applied on, see, x comma y means first x takes 10, y takes 20, adds it. 30 will get, 30 will be taken as x, and next 30 will be taken as y. You will get sum as 60, 60 as x, next y takes 40, 60 plus 40, 100. 100 will be taken as x, and y takes 50 plus 150 is the output in this way. Difference between reduce and reduce by key. It is difference between reduce by key and reduce. Reduce by key and reduce, the differences. Reduce by key and reduce by, yes. Groups. It groups and aggregates. Into groups and aggregates. Yes, groups and aggregates, right? Reduce by key, groups and aggregates. What is reduce? For cumulative aggregation, right?
Aggregates.
For cumulative, yes. For cumulative aggregation. Reduce by key and reduce by, reduce by key, groups and aggregates, reduce cumulative aggregation, right? Cumulative aggregation is directly to use this, but it won't give that. Reduce by key is not going to provide you that. For example, salaries you got of all the employees. If you want to get the salaries of all the employees, reduce by key cannot get it. Means all that, for example, particular department wise salaries or city wise salaries, you can get that reduced by key. For cumulative aggregations, go for reduce. Particular department wise aggregations, if you want, reduce by key. Or city wise, product wise, department number wise, gender wise, if you want to go for reduce by key. And for reduce, all that it gives the entire
So,
sum.
so this reduce can be applied on tuples, like list of tuples and all.
Reduce applied on list or anything. You can convert a list or tuple or set into RTD, right? On the RTD only you are going to apply. Second, it is a transformation. It is a transformation. It is an action. It is a transformation and it is an action. It is a transformation. It is an action. Applied only, right? Applied only on key comma value pair. Applied only on key comma value pair, right? But here Can we apply this reduce on a key comma value pair? Can we apply this on a key comma value pair? Right? No, we cannot apply. So R1 is not a key comma value pair. It's just like you got some elements. The elements are not like key comma value tag. Reduce. See the difference between reduce and reduce by key. Can't be applied. Can't be applied, right? Can't be applied. 1 second. Give me a yes. Okay. So understand this, it's a transformation, it is an action. Reduce is an action. Reduce by key is a transformation. Means if I apply reduce by key, you will get an RTD. But if you apply reduce, you won't get an RTD. You will get a Python object, right? And it can be applied only on key comma value. It can be applied on not on key can't be applied on key comma value pair. It can't be applied on key comma value pair, right? Yes. Understand the difference. Okay, fine. That's the main difference. So on RTD, anytime if you want the cumulative sum you want, the total revenue generated or the total salary is given, the total amount, if you want to go for reduce. But branch wise you want, or city wise you want, product wise you want, month wise you want, year wise you want, go for reduce by key. It won't give like cumulative sum, it just gives based on that. Is my voice clear to all? No.
Yes, sir.
Now, sum, max, min, count, all this I'll discuss. Huh? Sum, max, min, and count. Sum function, max function, Sum function, max function, min function, right? Count function. Sum function, max function, min function, and count. Is it mandatory to apply action on the OTT at the end? Yes, it's mandatory. Until action is applied, the flow won't execute. How many transformations you are providing, right? How many you are providing until action performed, the OTD is not going to get executed, right? Yeah. Observe this. R1 dot sum, R1 dot max, R1 dot sum, R1 dot max, R1 dot min. Sum is 150, max is 50, min value is 10.
Vijay, what is the difference between the sum and reduce?
Count. Okay, yes, I'm coming to it. Yeah, I'm coming to it. R1 dot sum by R1 dot count. This is for average. R1 dot sum.
Parenthesis is
brackets.
sum.
Parenthesis you're missing.
Yeah, yeah. R1 dot sum means you should be brackets are missing, right? 30, right? R1 dot sum by R1 dot count. Yes.
Don't we have average function instead of sum by count?
No, no average one. Okay, 1 second. Hmm. So all these are the functions. 1 second, this I'll remove. Now, sales dot reduce, sales dot sum. Sales dot reduce and sales dot sum, right? So here we have got two partitions here and we've got two partitions here. Assume that here we've got okay, 1000 and 2000, 3000 and 4. Okay, here two partitions means first partition, second partition. Here first, okay, first you forget about the sum, reduce. P1 partition, P2 partition. P1 stored in S1 slave, P2 stored in S2 slave. Individual results of each partition will be collected and aggregated in another machine, S3 of Spark cluster. Means this 3000 is the sum, this is 7000 is the sum. Both are collected, the results, individual results are collected, and their sum will become 17,000, right? Yes. Final result is collected into client machine. Here, parallelism while performing sum. Here it is faster. Here all the partitions are collected and computed at client level. All these are computed at the client level, right? So all these are collected and sum is 1000. Final result is 1000 is stored in the client. Here no parallelism while performing sum. Slower as compared to reduce, right? So here
Here is no role of the S3.
10 partitions are there, that 10 partitions, they will be executing parallelly and they will, so here P1 partition, some will be computed, P2 some will be computed, P3, P4. And their individual results will be collected into another machine computes. But here it's not like that. All that will be collected into client ends. There's no parallel processing at all for performing any of it. Right? That's the main difference. Sum and this.
So when to go for this sum and when to go for reduce if we do not have partition?
Apart from this, so if you want to achieve more speed, high speed, right? If reduce, if you are using, we get more speed. But sum is just one aggregation. So sum agree instead of sum, you can go for reduce. But all the for remaining aggregations like max, min, or the remaining things, you can use sum. But instead of sum, go for reduce only. Both the outputs will be same.
So always we can go for reduce instead of sum.
But there is also, as it is given max, min, count, also sum also it is given. Right?
Okay.
Fine. Okay. Now next is if you want to save. So everyone have got knowledge on HDFS, right? I already forwarded HDFS videos. Video is forwarded. So you have got knowledge on HDFS. The notes also I can forward you if anyone doesn't have knowledge on HDFS. So here, what is the last one? Save as text file. Save as text file. Enter. Save as text file and path. Saving the output of a RTD as a text file, right? Okay. So everyone also have got knowledge on yarn, right? Everyone has got the knowledge on the yarn. Yes. The last week I discussed about yarn and HDFS. Okay, just observe. Okay, just to go to this. Control Shift T, opening one more terminal. Control Shift T, opening one more terminal, right? Yes. HDFS. Now use this command HDFS DFS. Hadoop FS you can use HDFS DFS. HDFS DFS, right? Hyphen ls slash you can say HDFS. Previously Hadoop FS was the command. HDFS DFS hyphen ls to see what all the time. Okay. Start hyphen DFS. Start whenever you get that kind of error, right? Start your services. Start hyphen DFS dot sh. Start hyphen yarn dot sh. Okay. JPS, Java process that are running. JPS. Okay. For saving any processed data, right? For saving any processed data. Save as text file. Saving the output of a OTD as a text file. Yes. HDFS, DFS, hyphen ls slash, right? This was all that files and access under this root directory. So I'll create one directory, HDFS. How to create a directory in HDFS? HDFS DFS hyphen mkdir
MKDA.
slash Pyspark 6:30 p.m. Right? I created one folder, creating one folder, right? Okay. It's an empty folder, right? It's an empty file, empty folder, HDFS directory. Now, okay. Control L. Right. Observing this Pyspark. Yes. X is a list. I have parallelized and converted to an OTD. R1 equal to SC dot parallelize X. Now this R1, I want to save it. R1 dot collect. If I say R1 dot collect, okay, you get this output 10 to 50. But R1 dot save as text file for saving this in R1 dot save as a capital, save as text file, txt text file. HDFS colon /. So we need to say HDFS colon localhost means from the same system. localhost. The port number is 9000 slash. Where can you see this port number means? See, if you minimize this, we go to this Hadoop ecosystem and this Hadoop folder, etc folder, Hadoop 4-site.xml is there. 4-site.xml. Open with mouse pad. You can see this HDFS localhost 9000. Your file system, default file system name, right? HDFS localhost 9000, right? Where you can store the same thing, okay? Where you can see this in Hadoop installed folder, in Hadoop etc folder, 4-site.xml. In etc in Hadoop, you can see 4-site.xml. You can see that, right? Yes. So that's why HDFS localhost 9000. In this, your directories are created. In this file system, right? In this file system, your what is that directory name which was created? Pyspark 6:30 p.m. right? Pyspark 6:30 p.m. In that one more subdirectory res1 should be created. In that res1 subdirectory, whatever that file, whatever this is going to be stored, right? Whatever this with the default name, part file is going to get created. So in HDFS localhost 9000, within that a directory already we have created it. In that directory, res1 is subdirectory which creates. In that a file with the default name will be created. A file. res1, right? Say enter. Okay, it's saved. Go and check whether it is saved or not. res1 is the subdirectory name. HDFS DFS -ls slash Pyspark 6:30 p.m. right? Within that you will see a folder with the name res1. Within that res1 you can see the file. Can you see a file with the name res1? Within this res1, check res1, right? You will see a file with the name part file. You are going to see a part file. A file with the name part, P-A-R-T, with 5 zeros. Now read it. -cat, you say. -cat for reading a file. Pyspark 6:30 p.m. res1 slash PART -1 2 3 4 5. 1 2 3 4 5.
What is the another file? Underscore success.
It's not, it's normal file. Whenever it is succeeded, it will say success. Otherwise, failed means it will say failed. We have nothing to do with that. Whenever you successfully, if the file is created, it will say that. Yes. 1 2 3 4 5. It reads that whatever five elements were there, right? In the RTD, 5 elements were there. 5 elements. 5 elements we can observe here.
If I want to specify a specific name, then I can just give that name also, right? Inside that save as text file.
You can give only the directory name, file name can't be given here. You want your full file name? Yes. No, we cannot give the file name here, only the directory name it takes.
So by default, how many partitions it creates for save as text file?
Yeah, next time I'm going to discuss about those partitions. It depends upon your data, right? And the number of partitions. Next is increasing or decreasing the number of partitions. Increasing or decreasing the number of partitions. Next time. Control S. Increasing or decreasing partitions. Increasing the number of partitions while parallelizing.
Vijay, I have one question. Suppose instead of saving it in the HDFS path, right? If I want to save this file after processing it, I want to save it in the S3 bucket, suppose. Then how do we do that? Do we need to specify all the connection information using the save as text file, or we can't do that?
Save as text file, right? For saving within the HDFS.
Okay, we can't go to the other environment.
Save as text file. Okay, we want to save in a. This is for HDFS environment.
No, basically, even in AWS, right? We generally process the data using AWS Glue, right? So during that time, so I wanted to save the output in a S3 bucket storage system
Yes, yes.
because I'm not using the HDFS as a storage. Instead of it, just we are using the Pyspark and AWS Glue, where we run that Spark process, right? And I wanted to run the output in the
Yes,
S3 bucket.
We have a command to store in S3 also. I'll let you know about the command. Increasing the number of partitions while parallelizing. X equal to, once not here, and Pyspark. Ten, 20, 30, 40, 50, 60, 70, 80, right? I got a list. SC dot parallelize. SC
Sir,
dot
you missed comma, sir, 60, comma 70.
R1 equal to SC dot parallelize. Yes, SC dot parallelize of X. X is what? Python object. Now, first I want to know how many partitions are there in this RTD R1. How will you check? How will you know how many partitions are there within this RTD? Means we have got a command. Get num partitions. N capital. Get num. P also capital. Get num partitions. R1 dot get num partitions, right? Yes. R1 dot get num partitions. Get num partitions. How many partitions? One. I want to increase the partitions. I want to increase here. I want to increase the partitions while parallelizing. While parallelizing. I want to increase the partitions while parallelizing. Check it. I want to increase the partitions while parallelizing, right? Yes. R2 I'm creating. Now R2 I'm creating R2 equal to SC dot parallelize. Again I'm parallelizing. Parallelize. SC dot parallelize of X comma 2. SC dot parallelize of X comma 2, right? X is what? Less. Python object comma 2, right? Yes. R2 dot get num partitions. R2 dot get num partitions. R2 dot get num partitions for R2, right? How many partitions? 2. Here, what is the difference between this statement and this here? Parallels of X comma 2 means I want 2 partitions. Now save this R2. R2 dot save as text file. R2 dot
What is the benefit for increasing the partition here with all of it?
yes, I'll come to it. R2 dot save as text file.
I think it will improve the performance, I guess.
Yes. If more partitions, if your partitions are increasing, right? Will be stored across multiple systems and more parallelism you get. R2 dot save as text file. Yes, change this RES2 you say. RES1 is there, right? Change to RES2. Check it. Okay. It's not an error, it's just a warning message. Okay. Whenever you are parallelizing itself, only you can give that number of partitions you want. 2 you want, 3 you want, how many you want, you can specify. Now go and check in this. Go and check in HDFS. HDFS DFS -cat /RES2. RES2. In this, you will see two part files you will be getting. Part 000 and part 0001. Two part files will be generated. See, part 000, part 0001. How many elements are there in the RTD? Yes. Yes, two files we will get. In the two files, you will see the data. Whatever data is available, we'll be seeing here, right? So you can check it. Cat 000, you see the data. You will see some 2 or 3 elements in this. All the 5 you have seen in this, in the second file will be empty.
I think you are checking in RS1, RS, R,
Sorry, sorry.
RS2.
RES2, right?
Yes, sir.
RES2. Part of RES1. RES2. Sometimes you will get 2 files and 2, 3. Sometimes the partitions are like 4 elements you see. One element you see in that 000. One element you see in 000, right? Sometimes all the 5 elements will see in one file, the other file will be empty.
So on what basis it is distributing the data over partitions?
10, 20, 30, 40, 50, 60, 70. First 4 elements into this, next 4 elements in that. Here, first 4 elements you got into this partition, next 4 elements you can see this. So,
sir, on what basis it's distributing? Let's say we give 2 or 3 partitions.
whatever data like hash partitioning it uses, right? So generally, whatever elements are there, it will divide into 2 and it will first part into one partition, second part into another partition. It's fine.
Okay, so it will equally divide across the partitions.
Equally divides, right? If you got, for example, male data is there, female data is there. In one partition, you will see male data, in another female data. Department 11 is there, 12 is there. Department wise, okay? In department 11 in one partition, you will see department 12, you will see in one partition in that way. Here, normal elements are there. So in the coming examples, you will observe, right?
And one more question is, so if we load to the same directory, so let's say first time we loaded and second time also loaded, again it will store in a different partition, right?
The same directory can't be used in HDFS. Already, if the directory is existing, we cannot override the directory. Overwriting is not possible in HDFS. We cannot overwrite or we cannot modify in HDFS.
Okay.
So every time we need to create a new directory.
Because the files in HDFS are immutable, so that's the reason we need to create a separate directory.
Immutable. Okay, this is not required. So 4 files, 4 elements in this, 4 elements, total 8 elements. 4 elements in this 4. Now, more examples we observe in this. More examples. Okay, increasing, okay. If you can increase 2, you can give 3, you can give, right? Yes. But here, okay, go to this R2, right? R2. R2. R2 is the RTD name. R2 dot count, you see how many elements? R2 dot count. How many elements? 8. R2 dot get num partitions. How many partitions? 2 partitions.
2.
First partition for, second partition for. First 4 elements in the first one, second partition, right? Okay. But I see here, okay, I'll just copy this. but I doesn't want two partitions. Two partitions. Make it into one partition. I doesn't want two files. I want only one file. Okay. I doesn't want to make it into one partition. Make it into one partition and one file. For making into one partition, we have coalesce. COALESCE. We have coalesce. We have coalesce function. Which is a transformation function, It is a coalesce, it is a transformation only. It is a transformation, not an action. To decrease. It is to decrease or combine the partitions of a RTD. Right? Yes. It is a transformation to decrease or combine the partitions of a RTD, right? Okay. So here just now I said R2.getNum partitions. R2.getNum partitions. R3 equal to R2 dot coalesce. R3 equal to R2 dot coalesce of 1. R3 equal to R2 dot coalesce of 1, right? R3 equal to R2 dot coalesce function, coalesce of 1, right? Now we see R3 dot getNum partitions. R3 dot getNum partitions, we'll see only one partition only. But still in R2 you'll see two partitions. RTDs are immutable. We cannot modify or change. Once RTD is created, you cannot modify or change. You can take its output and you can create another RTD. See, on R2, I performed coalesce transformation. The result is in R3. In R3, you can see one, but in R2, still two, right? Yes.
So if I'll save R2, it will be still 2 files, and if I'll save R3, it will be a 1 file. Right?
One file. Can I increase? Can I increase the partitions using? Can I increase the partitions using coalesce? Can I increase the partitions using coalesce?
No, sir.
For that, we have parallelized the method, right, for increasing.
Can I increase the partition using coalesce? Yes or no? For example,
No.
No, sir.
R4 is R4 I'm creating. R4 equal to R2 dot coalesce of 3. How many partitions were there in R2? 2 were there. Can I increase to 3 or 4? Into 4? Possible or not? Do you get any error here? Are you going to get any error in this? Enter. No error. Do you think of 4 partitions? No error. Do you think of 4 partitions are created in R4? R2, how many partitions? 2, right? Do you think in R4? Check this output. R4 dot get num partitions. R4 dot get num partitions. How many? 2.
So, sir, command will execute, but the actual output will remain unchanged for this one, the number of
Here,
partitions.
serious. Even though you in using coalesce, you can only decrease, you cannot increase. So even though you have given 4, you didn't get error, but see the number of partitions, you got 2 only. No. Can you increase the partition using coalesce? No. Even if you try to increase also, it will give the default partition. Using coalesce, we can only decrease. We can only decrease. But we cannot increase. We cannot increase.
Vijay, I have one question. Hello.
Yes.
Yeah. So while processing the data, right, we don't know the amount of data we get every day, right? So Spark will automatically partition the data based on the data set, basically. But how do I know that whether if I want to increase or suppose in a day, if I get 1 GB of data and the Spark allocates some 10 partitions, I got to know the 10 partitions, I can increase to 20 partitions. But tomorrow it may be 1 GB
What
only.
is the source of your data? From where the data is stored? HDFS? From
HDFS only.
HDFS, we need to load the file, right? We need to load the file.
Yeah.
In RAM, there won't be any data available initially. Whenever you trigger that flow only, one by one RTDs gets loaded, and into how many partitions you want, you can also specify the partitions by loading. In the next example, I'm going to show you while loading, how can we create the partitions, not while parallelizing. While loading also, while loading a file from HDFS, I can specify the partitions, how many. Yes. The previous one, right? R3.save as text file. R3.save as text file. Into how many partitions? R3. Only one partition or RES3?
One partition.
Okay. Check it here in this, after that, police. HDFS, DFS, RES3. Only one part file you will get. Only one part file, right? You can see all the files. Increasing the number of partitions. Two ways. Increasing the number of partitions, two ways. Increasing the number of partitions, two ways. By parallelizing, we need to specify number of partitions we want. While parallelizing, we need to specify the number of partitions we want. While parallelizing only, we need to specify the number of partitions we want. Next, while loading a file, from HDFS, for loading a file from HDFS, we can specify the number of partitions we want. While loading a file from HDFS, we can specify the number of partitions we want. While loading a file, how can we specify the number of partitions we want, right? For example, if there is a file, ls you say, emp1.txt is there. You got some employees, sample data, employees data, cat emp1.txt. You got like the ID, name, salary, sex, department number, some file records are there, right? Now, HDFS, DFS, put command, you from LFS to HDFS, how to copy a file from LFS to HDFS, DFS, put emp1.txt, emp1.txt into slash Pyspark, into Pyspark 6 p.m. 6:30 p.m. right? 6:30 p.m. Loaded. HDFS, check this. HDFS, DFS -ls slash Pyspark.
Hello, Vijay. Hello.
He is disconnected.
Yeah, he has some issue, I believe.
Okay.
Are you able to hear my voice now?
Yes, now you're audible.
Yes,
So
sir.
some connection error. I was out of the meeting. While loading a file, we can specify the number of partitions we want. How many partitions we want can specify while loading files. Okay, fine. So just copy this file. Now creating an OTD. In the last class, I spent 3 ways to create a, now creating an OTD. Creating a OTD. Whenever we load a- whenever we load a file
Your voice is
from
breaking, Vijay.
context
Vijay, your voice is breaking actually. We can't hear you
using
properly.
Spark. Okay. Is my voice breaking to all?
Yes.
Yes, yes.
From now
I think
itself or
your
at the
voice.
starting of this?
No, just now it was for a
From now,
minute, but now I think it is fine.
Yeah, now it's fine. I think your network range is less actually. I can see. Maybe you can. Wi-Fi range is less.
now is my voice clear or not? Hello? Now can you confirm, right?
Yes, clear.
Now
Now
it's
it is
clear.
clear.
When we load a file from HDFS, when we load a file from HDFS using Spark context, using Spark context means CSV is created. Now see this. Now I'm loading a file. Now I'm loading a file from OTD, from HDFS. R1 equal
Your voice not clear actually, not audible properly.
And you're again breaking actually. Again
Sorry?
breaking.
Not audible.
One second. Now is it fine? Hello?
Fine.
Yeah.
Whenever we load a file from HDFS using Spark context, then RTD is created. So from HDFS, if you are loading, okay. R1 equal to sc dot text file, sc dot a text file. Take this HDFS colon / localhost colon 9000 / Pyspark 6:30 p.m. right? Slash emp1 dot txt file, right? In Pyspark 6:30 p.m. you got emp1 dot txt file available, right? Yes. Check it. How many partitions you got here? R1 dot get num partitions. R1 dot get num partitions. How many? 1. But I want to increase the number of partitions. To increase the number of partitions. To increase the number of partitions, then R2 equal to, just I'll say R2 equal to RTD2. One more time I will load it. R2 equal to sc.text file local paths. Okay. emp1.txt into 3 partitions. I want 3 partitions. Comma 3. Comma 3 I have given, right? Yes. Now say R2. R2 dot get num partitions. R2 dot get num partitions. How many? 3. R2 dot get num partitions. How many? 3. So in this way, you can specify while loading the file emp in from HDFS. So loading a file, you can specify the number of partitions by loading only. This way. You can see you can 3 part files will be created. 3 part files are going to be created, right? This how to decrease the partitions? How to decrease the partitions is
Coalesce.
using coalesce. How to increase? While loading or while
While loading.
parallelizing, right?
Yes.
Now, I will discuss different ways of creating partitions. Sorry, RTDs. So what are the different ways of creating RTDs? 3 ways I said.
From text file.
Yes. Different ways of creating RTDs. How many ways? 3 ways. 3 ways. First way, whenever we load a HDFS file using Spark context, same the previous one that I'll copy it. Whenever we load HDFS file for Spark context, RTD is created. This is the first way. Second way, whenever we perform, We perform, yes,
Transformation.
transformations on a RTD. Then the resultant is also a RTD, is also a RDD. R2 equal to if we parallelize a Python object, then RTD is created. If we parallelize a Python object, then RTD is created. R1 equal to SC dot parallelize of X. Okay, different ways, 3 ways, right? Yes. Okay, loading data and filtering. Loading data and filtering. Yes. Everyone are in the WhatsApp group, right? Pyspark WhatsApp group. I'm talking about Pyspark WhatsApp group, right?
Yes,
Everyone
sir.
are in the Pyspark WhatsApp group. In that
Yes.
notes, I'm forwarding
Yes.
regular basis, right? After the class also, I'll forward these notes what we discussed.
Okay, sir.
Okay, just observe here in this. So R1, right? Just R1 equal to sc dot text file loading the task. Filter those employees. Filter those employees whose salary whose salary is above 20,000. Whose salary is above 20,000, right? Yes. R1 equal to just now. R1 equal to, right? sg.text file, localhost 9000 Pyspark in the tmp1.txt, R1.collect if you say. So the number of records you get, right? Yes. You will get first record. You see this records, 5 records you put list. Now I want to filter only those whose salary is about 20,000. How can I do this?
Using filter.
Filter
Lambda functions can apply in the list. A2 greater than 20,000.
okay. Okay. Each one first string, second string, third string, 5 strings are there. Each string is one record. Each string is one record. Second step 2. Step 2 is split. Splitting each record. We get a list. If you split each record, right, each string, we get a list. From that list, using indexing, you can access it. R2 is an RTD. You are going to get R1 dot map of R1 dot map lambda. Lambda x. X means each record. X means each record. X dot split. X means each record. X dot split based on comma. Splitting based on comma, right? X means each record, each string split. Means for every record you will get a list. For every record you will get a list. R2 dot collect you say. R2 dot collect you say, right. For every record you will get a list. Once you got a list, from each list, extract only names and salaries.
Vijay, why it is coming U prefix in every record?
Here it's UTF encoding, right? So we have nothing to worry about it. Your UTF encoding you will get. So nothing, it has nothing to do. While in the output it will display, but nothing. Step 3. Extract only names and the salaries. Extract only names and salaries. How to extract only names and salaries? R3. From R3 you are going to get from R2. How to get from R2 dot map again? R2 dot map. R2 dot map. Lambda x.
X
Lambda
colon
x.
X
colon
of 1,
X of 1.
x of 1.
comma,
X of 1 means what? Name.
name.
X of 1 is what? Name. Right, yes. And next, what is the other one you
Salary.
want?
Salary.
X of
X of 2.
One second. So list of strings you got, observe carefully here. You got list of strings, even salary is also a string. Salary is also a string. So I need to say x of 2, x of 2. In Python, how to typecast a string to int means just say int of, just int of x of 2, that's it. Int of x of 2. How many brackets? This is bracket for tuple and one more bracket for map. Totally 3. Now R3 dot collect. You can see only the names and salaries getting extracted, right? Names and salaries only getting extracted. Next
And
filtering.
Vijay, one moment. Here, R2 dot no. When you perform this map lambda dot split based on the comma, how it's getting splitted in the list in
Here, what is X here?
yeah.
X means this string, first string it takes. X takes the first string. If we split it based on comma, if I split it, you will get list of 5 words. If I split a line, you will get words, right? This string
Is
also,
it no? It will be a split always with the string only because
split only works only on strings. You can split only a string into words, list of words. Right? Now step 4,
okay.
filtering. Step 4 is filtering. R4 equal to R3 dot filter. R3 dot filter, right? BDA lambda X. Filter, how to filter? Only those X of 0. X means each tuple. X means each tuple. From each tuple, X of 0, X of 1. Salary I want, X of 1. X of 1, what is the condition? X of 1 should be greater than 20,000. Only those tuples you extract whose salary is above 20,000. That's it. R4 dot collect. Only those employees whose salary is above 20, right? Sonu, Sony and Sita and James. Sony, Sita and James, right?
How do we avoid this unicast U because this is always coming from the prefix in the output.
What is it?
U is coming, right? Unicast. So how do we avoid this U from the?
It is nothing to do with that. Just you will be, while displaying output, you'll be getting it, right? Every time. Whenever there is a string, you will be getting it. Wherever you
So
get.
is there no? Is there?
First
There's no way to be
integer is there.
avoid
Integer.
this UI into the.
Nothing. So you got integer. For that, there is no U. Only for string you will get. Wherever there is this string, only for strings you will get it.
But can't we avoid that string, that U per string?
No.
Because in the output result, it is not looking good, right?
If we share this output to the client, it's not a readable for him, right? It's like kind of like some
Not
other
in a
format. So
format.
yeah, proper format. Yeah.
You will, while storing this data into this HDFS, you won't see all this. The final output you will store in HDFS, right? Whatever output you get out for all this, you are not going to see this. Here you will be able to see, right? After processing the result, whatever we see, it will be in normal format.
So while saving into the HDFS, it will be automatically remove this.
Yes, you won't have these things.
Okay.
Sir, this task is happening over multiple steps.
1 second. So first what I did? First what was done? First load that, split it. For each split you will get a list. From that list, extract only the required things. After that, I want only the condition whose salary is about 20,000.
So here this operation is happening over multiple steps here. So can we avoid, or it's mandatory to break into steps and then perform this task?
So here, directly on the string, you cannot apply that. There are no, see here, this is entire thing is one string. On this string, you cannot apply any condition.
Yeah. So we did a split. So after split, can we do rest all operation in one line?
Yes, after splitting, you got list, you got list of, for each every employee, you got one list. If you want, you can
Mhm.
perform, we can perform this on this. Don't, step 3, this is not required. Directly you can go with this.
Okay. Yes. So once we have splitted the data with comma separated, so then we can combine multiple steps.
Yes. But this all, okay, you are taking some steps. Next, I'll be discussing about data frames. Here, we doesn't have any schema here. The output doesn't have any schema. What is 30,000? Just like a database table column names, we are not getting any column names here. The final output, it's schemaless. But next data frame, right? A schema RTD we call like data frames. You will get like a tabular format. RTDs with schema we got, like we say that schema RTDs, right? Fine. More discussion of this on filtering operations I'll discuss right in the tomorrow session. Just 1 second. So there's some groupings and aggregations and filters are there. So yes, groupings, aggregations and filtering. Next, I'll complete those tomorrow. And mostly next I'll be spending more time on this data frames and Spark SQL. Mostly like next Saturday, I'll be starting with Spark SQL, data frames by RTDs, data frame, RTDs with schema we call like data frames, right? Lot of discussions where we can create a data frame APIs and performing querying on the. I'll forward you these notes, and once tomorrow, actually I'm out of station. I'm taking class from somewhere else. So that's why you got some network issue. Tomorrow, like I'll be back to Hyderabad, but I'll be traveling. But tomorrow I want to take class somewhere at 1 hour earlier, right, to the regular timing, 6:30, right? 5:30. For only for tomorrow, right? Next week again we'll go at 6:30 only. So just 1 hour early to the regular timing. We'll start at 5:30 p.m. IST. 5:30 to somewhere like 7 by the take, right? I need to leave. Continuation to this groupings and aggregations, the other things I'll discuss. Right?
Sir, please discuss on how to, using Jupyter notebooks, because when data frame comes, right, then Jupyter
Compulsory,
notebook.
all the data frame concepts I'll show on Jupyter notebook only. Yes. Okay, fine. So I'll stop for now. We'll continue tomorrow. I'll forward you the notes in the group. WhatsApp group.